All right, guys, so the goal today is to talk you through some definitions, terms of motion, make sure that we're all on the same page, we're talking about the same thing, and hopefully give you a couple of examples with them as well. All right, as much as we can. All right, now here's the terms that we're going to be talking about today. One thing that I need you to be familiar with first is this word vector. Now, if you've ever seen the movie Despicable Me, in the original one, Gru ends up going to the bank of evil, and he meets up with this guy who says, "My name is Vector, because I'm committing crimes with magnitude and direction. Oh yeah!" And so that's what a vector is. And so if you can remember that, a vector has direction and magnitude. All right? So anytime that we say something is a vector, and I underlined these three, displacement, velocity, and acceleration, because those are all vectors. So anytime you mention displacement, you need to give both the value and a direction. And I'm going to try to give an example of that here, a couple of examples in just a minute. All right, now I'm going to go ahead and go through the definitions. I'm not going to write them up on the board because this is a video. You can always just rewind and go see whatever I said. All right, so distance. Distance is how far it is along the path from point A to point B. Okay, so distance depends on the path that you travel. All of that distance would be considered distance. All right. Again, I'll give you some examples in just a minute. Displacement is just how far is it in a straight line from point A to point B. So point A to point B, that's your displacement. Now, you also need a direction. So you could say 10 meters to the right, or 10 meters to the north, or 10 meters up, right? Those all have a direction. Distance didn't have direction because your direction can be changing all along the way. But displacement has one value and one direction associated with it. Okay, again, I'll give you some examples in just a minute. We've got speed. Most of you are familiar with the word speed. Speed is how fast are you traveling. Now, we're going to deal with two different types of speed. Sometimes we'll be talking about average speed, which is the average over the total of the whole course of what you're doing. And then sometimes we'll use instantaneous speed. All right, so instantaneous. So this would be both actually speed, velocity, acceleration. We can find average and we can find instantaneous. Now, instantaneous is how fast am I traveling right now, right? If you are driving a car and you look at the speedometer, that tells you how fast you're traveling right now in this instant. That's an instantaneous speed. All right, that is not an average speed. The average speed, you would have to look at all the speeds over the certain amount of time, and you'd have to be able to put those together in a certain way to be able to get average speed. All right, now we have velocity, and recognize velocity is underlined. So velocity is a vector. That means anytime we talk about velocity, we need to talk about both direction and magnitude. The magnitude's easy, but the direction, we need to remember to talk about the direction as well. Okay? Now, velocity is defined as displacement over time. Speed, you probably have heard of before. Speed is distance over time, so the total distance you traveled divided by the amount of time it takes you to go. That would give you your average speed. Velocity would be your displacement over time. Now remember, displacement is how far was it straight from point A to point B. That would give you your average velocity, would be total displacement over total time. Now, instantaneous velocity is kind of interesting because your instantaneous velocity is the same as your speed, your instantaneous speed, except it would also have a direction. Okay? So our first example here is we have a student that's walking all the way around a track in 5 minutes. All right? So this track is 400 meters all the way around. Okay? It's 70 meters across. That's kind of the width there. It's 150 meters end to end. And again, the whole total distance is 400 meters around. Okay? That's a pretty typical track. I rounded some things to simplify it, but that's the idea. So let's see if we can talk about each of these. So it says we start, let's just say we start right here. And we walk all the way around the track, 5 minutes. Okay? what is my distance? Well, the distance is the total path that I walked, which would be 400 meters. All right, 400 meters. Now the next question would be, what is my displacement? Well, remember, displacement is how far is it from point A to point B in a straight line. So if I start here and I go all the way around and I end there, my displacement is 0. It's 0 because there's no distance between my starting point and my ending point. It doesn't matter what I did, right? If I was standing here and I saw a bee land on my shoulder, rather than being nice and calm like I should be, I'd be going, ah! Running all over the track and finally coming back here. I'd be like, is he gone? Is he gone? I'd have a pretty high distance traveled as I was running around the track like crazy, but my displacement would still be 0 because there's no distance between my starting and ending point. All right? So that's going to be important as we go forward. Difference between distance and displacement. All right? Now, speed. Speed. Let's find average speed. Okay? To get the average speed, we need to do distance over time. We already talked about the distance, right? The distance was 400 meters. And the time was 5 minutes. Now, if I'm doing this in SI units, which I should, I actually want to do it in seconds. The distance should be in meters and the time should be in seconds, not minutes. So you have a choice. You can either do it in minutes and then change it later, or you can just say, well, 5 minutes times 60, that would be 300 seconds. So I'm going to go ahead and change this to 300 seconds. And when I divide, I end up getting 1.3 meters per second. So that would be my average speed, is 1.3 meters per second. Now, if that speed stayed the same all the way around the track, then my instantaneous speed at any point would also be 1.3. Because if I have a constant speed, then the instantaneous speed should be the same as the average. All right? Now, next question is, what is my average velocity? Well, remember, average velocity is displacement over time. For this situation, walking all the way around the track and ending where I started, my displacement was 0. So we go 0 displacement in 300 seconds, and I get 0 meters per second. My average velocity is 0. Now, I know some of you are like, but I've been walking the whole time. How are you going to tell me my average velocity is 0? Well, remember, velocity is a vector. Vectors have direction and magnitude. So yes, there's always the same magnitude. But at this point, your direction is to the left, right? I'm going 1.3 meters per second to the left. When I'm over here, I'm going 1.3 meters per second down. Right? When I'm down here, I'm going 1.3 meters per second to the right. Right? And so on and so forth all the way around. Okay? Now what I'm writing here is the instantaneous velocity. Right? I'm going 1.3 meters per second to the left right now. I'm going 1.3 meters per second down right now. Now what happens is, if I do 1.3 to the left and I do 1.3 to the right for the same amount of time, those two are going to cancel out. 1.3 to the left, 1.3 to the right, they cancel each other out. That gives me 0. So you'll notice that no matter where that vector is, it's going to end up giving you 0. All right? All right, so same track, but this time, number 2, this time we're going to go halfway around the track in 5 minutes. We'll keep the 5 minutes. All right? So that means I'm going to start right here. We'll start at the top, just so we have the same starting point. I'm going to go halfway around the track, which means I'm going to end right there. Okay? You ready? Okay, so first question. What is the distance traveled? Well, hopefully you're thinking, well, it's 400 meters all the way around. If I only go halfway around, my distance is 200 meters. All right? So distance, 200 meters. Next question. What is my displacement? Remember, it has magnitude and direction. So displacement, that is how far is it from my starting point to my ending point. We didn't use this information earlier, but we're going to need it now. Okay? From here to there, how far is it? Well, it tells me it's 70 meters across the track. So that means from here to there is 70 meters. That's the magnitude. So I'd say 70 meters, and then I need a direction. If I'm looking at my picture, I could just say 70 meters down. All right? If you are more comfortable saying, let me just give you a little compass rose with north, south, east, west, then you could say 70 meters to the south. Okay? But it always shows you which direction you've traveled in. So it needs to be down this way, however you end up doing it. Okay? So distance 200 meters, displacement 70 meters down. All right? Now, speed. Again, let's look at average speed. Okay? So average speed, we're going to take the total distance that we traveled, which was 200 meters, and then the total time, right? Remember, average speed is distance over time. So distance was 200 meters, time was 5 minutes, which again, I'm going to put into seconds. Remember, we want it in our SI units. So 200 meters divided by 300 seconds, and hopefully we get 0.67 meters per second. And yes, I'm rounding it. The units came from here, right? If you put the right units in the equation, you're going to get the right units out. Okay, so that is my average speed, 0.67 meters per second. All right? Now, that would also be the same as my instantaneous speed because we're saying we go at a constant pace. So therefore, I'm going to have the same 0.67 meters per second at any point in time as well. All right? Now, let's look at velocity. Okay? Remember, average velocity is displacement over time. So, the displacement, the value was 70 meters, right? Because that's how far it was from the start to the end. And the time was still 300 seconds. So 70 over 300, which should give me 0.23 meters per second. But remember, velocity is a vector, so we need a direction there as well. So the direction that we're going to give is down again. That's the average, so down. Or south, however you want to do that. All right, speed, velocity. Now, if it asked for the instantaneous velocity, remember, instantaneous velocity is the same as speed, but I just need a direction. So my instantaneous velocity here would be 0.67 to the left. Here, it would be 0.67 down. Here, it would be 0.67 to the right. Okay, so in each, I could do one here, right? 0.67, kind of southwest there, or, you know, whatever. We can name that with an angle. We'll do more with vectors later. For right now, I just want you to get the idea. One more example. We're going to go something completely different this time, all right? All right, you ready? Here we go. Last one. This one's going to be a little bit different. I'm not running around the track anymore. I realized how stupid that was because I went all the way around the track. My displacement was 0. It was totally pointless, so we're not going to do that anymore. We're going to go ahead and do a little bit more walking in a different way. It's usually helpful if you have changing things going on to take just a minute to draw a picture. So that's what we're going to do. Student walks north at 2 meters a second. So this is north. If you need to, draw your compass rose, north, south, west, east. So north, 2 meters per second for 30 seconds. And then walks east, so that's now that way. Probably going to be a little bit less because it's 1 meter per second for 50 seconds. All right, Now, the first question is, what's the distance traveled? The formula says that the speed is equal to the distance over the time. My speed here is 2 meters per second, so I'll just put 2 there, is equal to the distance, which is what I'm looking for, over the time, which was 30 seconds. Okay? Now, you'll notice if this is meters per second and that's seconds, if I multiply both sides by 30, I can solve for d. So I multiply both sides by 30, the seconds are going to end up canceling out, and I'm going to get 60 meters equals d. So that's this one right here. This one right here is 60 meters. All right, so that's the distance that he walked in those 30 seconds. Now we're going to do the same thing for this one right here. Okay, again, you can do speed equals distance over time. So we take our speed, which is 1 meter per second, is equal to distance over time, which is 50 seconds. So 1 equals distance over time. Now notice, if I use SI units, meters and seconds, then I don't need to put all the units in there because units are going to take care of themselves. Okay, so this is why I encourage you to always put it in meters, always put it in seconds, always put it in kilograms, because those are SI units. Okay, now to solve for d, multiply the 50, and we get 50 meters equals d. So 50 meters. So what is the total distance traveled from point A to point B? Well, 60 and then 50. So my total distance is 60 plus 50, which is 110. All right, so 110. All right, now what's the displacement? This one's a little bit harder. Okay, you're going to have to use a little bit of your math skills here from geometry. Okay, starting point, ending point. Remember, displacement is how far is it in a straight line from point A to point B. So that would be this right here. Now, I was kind and made sure that it was north and east, which are a right angle. How do you find the length of the missing side? That's right. You got to use the Pythagorean theorem. You got to do a squared plus b squared equals c squared. So your a is going to be the 60. Your b is going to be the 50. And that should equal then c squared. So I get 6,100 is equal to c squared. Square root both sides, 78.1 meters per second. Sorry, not meters per second, just meters. Now, that's the magnitude of the displacement. Now, if you wanted to get a direction, you would need to find this angle here. Okay, and we can define directions based off of angles. For now, I'm not going to ask you to do that. At some point, though, we're going to figure out how to get that angle, I hope. All right? For now, don't worry about it. Right now, I want us to worry about distance, displacement, velocity, speed. Okay? So, displacement would be 78.1 meters. All right, speed. Let's find the average speed. Now, don't you dare, because the first thing people do is they go, oh, 2 plus 1 divided by 2, that's 1.5. You can't do that, because you're traveling at this speed for less time than you're traveling at this speed. So your average should be closer to this one. Remember, average speed comes from distance divided by time. What is the total distance traveled? The total distance was 110 meters. And the total time, 30 seconds plus 50 seconds, a total of 80 seconds. 1.35 meters per second. Remember I said it was going to be closer to this number than that number? Right? That is because we spent more time at this. So the average should be closer to that one. Average velocity? Displacement over time, right? The displacement we found. The time was 80 seconds. And I get 0.98 meters per second. And again, this would only be the magnitude. The direction would be whatever angle we calculated there, which again, we're not going to worry about that for now. Okay? Now, if it asked for the instantaneous velocity here would be 2 meters per second up. Instantaneous velocity over here would be 1 meter per second to the right. But when you put all that together and you get an average of all these little vectors and directions, it ends up giving you 0.98 up to the top right. We're not going to call that northwest because we only, northeast, because we only say northeast if it is exactly 45 degrees. Because these are different, then we know it's not perfectly northeast. It's going to be a little bit more north than east. All right, so again, we'll get to the angles later. You're welcome to try it now if you want. But for now, we're just going to leave it as is. Okay, so hopefully that's helped give you a couple of examples of how we can use distance, displacement, speed, velocity, a little bit of connection with the instantaneous, which is right now how fast, versus the average, which is overall how fast is he going. All right, these definitions are going to be really, really important as we get further and further into physics here. All right, looking forward to doing more with you, and we'll see you in class.